Okay, here are some indices questions. Something like this, say solve for x. Well, as we said in class, what we need to do is we need to get both of these numbers here to the same base. Because if we have something like, say, 3 to the power of 10 is equal to 3 to the power of x, well then 10 is equal to x. So if we get both of these to be, say, the same number, well then whatever up here on the top will be equal to each other. They'll be equivalent. So let's change 27, which is equal to 3 to the power of 3. That's to the power of 2x, is equal to 9 is equal to 3 to the power of 2, and that's still 4. So I've swapped these 27 to 3 to the power of 3 and 9 to 3 to the power of 2. Now when I've got these here, a power to a power and a power to a power, I times them. So that's going to give me 3 to the power of 6x is equal to 3 to the power of 8. Now you'll see we've actually done it. We've actually got our 3 as a base. So now we can say that 6x is equal to 8. X is equal to 8 divided by 6, and you're solved. Well, you can simplify that a little bit, maybe make it 4 over 3. But that's the solution to that one. Okay, let's have a go at one more. We'll say something like 1 divided by 2 to the power of x is equal to 32. All right, well again, I'm looking for a number that both of these can be the same. So 32 is 2 to the power of 5, I think. 2, 4, 8, 16, 32. So I have 1 over 2 to the power of x is equal to 2 to the power of 5. The only problem is, of course, that this 2 to the power of x is on the base. It's on the bottom. It's a denominator. So I need to move it up. And the rule you need to know is that 2 to the power of minus x is equal to 1 over 2 to the power of x is equal to 2 to the power of 5. So now we have minus x is equal to 5. And that means x is equal to minus 5. So we solve that. So 1 over 2 to the power of x, 1 over 2 to the power of minus 5 is equal to 32. Okay, let's have a go at another one. Okay, 5 to the power of x is equal to this here. So as we've done in all the previous examples, we tried to change these 25s and 125s into powers of 5. So 5 to the power of x is equal to 5 squared is 25. That's still squared. And 125 is 5 cubed. So that's going to give me, when I multiply these out, 2 by 2, I'm going to get 5 to the power of 4 divided by 5 to the power of 3, which is equal to 5 to the power of 4 minus 3, and that's equal to 5 to the power of 1. So 5 to the power of x is equal to 5 to the power of 1, x is equal to 1. And let's do one more substantial type of thing. We'll say the square root of 27 divided by 81 is equal to 9 to the power of 3 minus x. Okay, so the common base here, the one we're looking for, is 3. Okay, so I'm going to have the square root of 23 cubed divided by 3 to the power of 4 is equal to 3 squared to the power of 3 minus x. All just 3's, that's your common thing. So the square root of 3 to be cubed, I'll just slide this up a little bit, is equal to 3. I'm looking at this bit here, okay? It's equal to 3 cubed to the power of a half, the square root of it, you see, divided by 3 to the power of 4. And that's equal to 3 to the power of, and I multiply all of this stuff here. I multiply 2 by 3 minus x. That's going to give me 6 minus 2x. So let's keep going. That's going to give me 3, the top line here now. Okay, so that's going to give me 3 to the power of 3 over 2 divided by 3 to the power of 4. And that's equal to 3 to the power of 6 minus 2x. If I slide this up a little bit, that's going to give me, now 3 to the power of 3 over 2 divided by 3 to the power of 4 is equal to the power of 3 to the power of 3 over 2 minus 4 is equal to 3 to the power of 6 minus 2x. What's 1.5 minus 4? Well, 1.5 minus 4 is equal to minus 2.5. So it's 3 to the power of minus 2.5 is equal to 3 to the power of 6 minus 2x. Okay, that looks like it worked so far, but actually we've pretty much solved it. We now know that minus 2.5 is equal to 6 minus 2x. And let's bring this up here and continue on. That means let me bring, what I'm going to do is I like to get my variables, my x's onto this side. Well, it can be any side, but I just don't like the minus, you see. So if I bring it over to the far side, in other words, I actually add 2x to both sides, which is the formal way to say it. I'm going to get 2x on this side is equal to, there's my 6, I haven't moved that, it's still on the right hand side of the equals, and I take my 2.5 across to the far side over here. So in other words, I add 2.5 to both sides, plus 2.5. So 2x is equal to 8.5, and that means x is equal to 4.25. Now, x is equal to 4.25. And I'm just now thinking, let's go back to the original question up here. So that would mean that the square root of 27 over 81 is equal to 9 to the power of 3 minus, what was it? 4.25. 4 minus 4.25. So I just simplify that. Maybe someone can check and tell me that it works, that I did it correctly. Thank you. See you tomorrow.